Good day, space fans, and welcome to Astronomy Daily, your daily dose of everything happening beyond our atmosphere. I'm Anna.
And I'm Avery. It is Thursday, March 19, 2026, and we are recording this on what might be one of the most action-packed days in recent space history, because tonight, the most powerful rocket ever built heads back to the launch pad.
And while that's happening, we've got particle physics bombshells from CERN, a galaxy next door that's been hiding a dramatic secret, a bold new take on the search for alien intelligence, and the curious hunt for asteroids that hitch a ride alongside planets around other stars.
Buckle in, everyone. This is Astronomy Daily, and the universe has been busy.
Let's start with the big live one, because as you're listening to this, something incredible may actually be happening right now.
Tonight, Thursday, March 19th, NASA is planning to begin rolling the Artemis II Space Launch System rocket and the Orion spacecraft out of the Vehicle Assembly Building at Kennedy Space Center in Florida and transporting them on the slow journey to Launch Pad 39B.
We say slow, and we mean that literally. The crawler transporter that carries the rocket moves at a maximum of about 1 mile per hour. The whole trip covers roughly 4 miles and is expected to take up to 12 hours. It's not fast, but it is spectacular.
NASA confirmed the rollout target at 8 p.m. Eastern Time tonight, after a busy few days of closeout activities inside the VAB. There was a brief scare earlier in the week when engineers identified an issue with an electrical harness on the flight termination system of the core stage, which pushed the rollout date back to possibly March 20th. But teams worked quickly and made up the lost time.
And of course, the reason all of this matters so much is what comes next. Artemis II is NASA's first crewed mission under the Artemis program, the first time human beings will travel to the vicinity of the moon since Apollo 17 in December 1972. That's more than 50 years ago.
The crew of 4, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency mission specialist Jeremy Hansen have already entered pre-launch quarantine with plans to arrive to Kennedy Space Center on March 27th.
Victor Glover will become the first person of color to reach deep space and the moon's vicinity. Christina Koch will be the first woman to do so, and Jeremy Hansen will be the first non-American citizen to travel to lunar space. This mission is genuinely historic on multiple levels.
The mission itself is a 10-day free return trajectory around the moon. Not a landing, but a crucial crewed test of the Orion spacecraft's life support systems and deep space performance before later Artemis missions attempt a lunar landing.
And the first launch opportunity is Wednesday, April 1st, with a window that opens at 6:24 p.m. Eastern Time. Additional windows exist through April 6th, and there's another opportunity on April 30th.
This rollout itself is a milestone. It's actually the second time the rocket has made this journey this year. It rolled to the pad in January for initial testing, but a series of technical issues, including a liquid hydrogen leak and a helium flow problem, required it to roll back to the VAB for repairs in late February.
So tonight is the comeback tour. And if you're anywhere near Kennedy Space Center or just watching a live stream at home, this is absolutely worth staying up for.
A 53-year wait for humans to return to the moon ends this April. And tonight, the rocket that'll take them there is heading to the launch pad. That's story one.
Now, while all that Artemis excitement was building, humans were also doing extraordinary things in orbit, in not one, but 2 space stations simultaneously.
Let's start at the International Space Station, where yesterday, Wednesday, March 18th, NASA astronauts Jessica Meir and Chris Williams completed what's known as U.S. Spacewalk 94. They emerged from the Quest airlock at 8:52 a.m. Eastern Time and concluded their excursion at 3:54 p.m. A total of 7 hours and 2 minutes spent working in the vacuum of space.
Their task was to prepare the ISS's 2A power channel for the future installation of a new IROSA, an International Space Station Rollout solar array. These rollout arrays don't need a motor to deploy. The potential energy stored in the rolled-up carbon composite booms is enough to unfurl to full 19-meter length in about 6 minutes. Once installed, it'll be the 7th of 8 planned rollout arrays since the upgrades began in 2021.
For Jessica Meir, this was her 4th spacewalk, bringing her total EVA time to 28 hours and 46 minutes. For Chris Williams, it was his very first time stepping outside a spacecraft into open space. And after they closed the hatch, Meir had some beautiful words to mark the occasion.
She noted that March 18th was exactly 61 years since Alexei Leonov made the very first human spacewalk back in 1965. A nice piece of space history to carry out into the void with you.
This EVA had actually been a long time coming. It was originally planned for January 8th with a different crew, but to a medical emergency involving astronaut Mike Fink led to the cancellation of that spacewalk, and ultimately the unprecedented medical evacuation of the entire Crew 11 mission. So yesterday was the culmination of a very eventful few months at the station.
And while Jessica and Chris were suiting up at the ISS, over at China's Tiangong space station, there was an EVA of their own underway. On Monday, March 16th, Shenzhou 21 mission commander Zhang Lu and crewmate Wu Fei spent approximately 7 hours outside Tiangong installing debris shielding to the exterior of the 3-module station.
But what made this one especially notable was the milestone for Zhang Lu. It was his 6th career spacewalk, tying him to fellow Chinese astronaut Chen Dong for the record of most EVAs ever completed by a Chinese national. Zhang made his first trip to space on Shenzhou 15 back in late 2022 and completed 4 spacewalks during that mission. He's now matched Chen's tally of 6.
For context, the overall record for most spacewalks belongs to Russian cosmonaut Anatoly Solovyev, who completed a remarkable 16 EVAs during his career from 1988 to 1999. The American record sits with Peggy Whitson at 10.
So in the space of just 2 days, Monday and Wednesday, humans from 2 different nations conducted spacewalks from 2 different space stations orbiting Earth. That is not something that happened very often even a decade ago, and it's becoming increasingly routine.
The era of humanity as a multi-station spacefaring species is very much here.
All right, time to get small. Very, very small. Because this week, physicists at CERN's Large Hadron Collider made a significant discovery in the subatomic world.
The LHCb experiment, that's the Large Hadron Collider Beauty experiment, has detected a new particle. It's called the Xi-CC+, written as the Greek letter Xi with Cc+, and it's a proton-like particle known as a baryon that contains 2 heavy charm quarks and 1 down quark.
To appreciate why that's exciting, a quick refresher. A proton, the particle at the heart of every atom, is made of 3 quarks, 2 up quarks and 1 down quark. Quarks come in 6 flavors: up, down, charm, strange, top, and bottom. Most everyday matter is built from the lightest 2, up and down. The others are heavier and more exotic.
The Xi-CC+ is like a proton that's had a dramatic upgrade. Its 2 up quarks have been replaced by 2 heavy charm quarks. And because charm quarks are far more massive than up quarks, the resulting particle weighs roughly 4 times more than an ordinary proton.
This is actually only the second baryon ever detected that contains 2 heavy quarks. The first, also discovered at LHCb back in 2017, had 2 charm quarks and an up quark. This new one has a down quark instead, and despite the similarity, it's predicted to be up to 6 times less stable, meaning it flashes in and out of existence even faster than its cousin.
The discovery was announced this week at the Rencontre de Morillard Conference, a prestigious annual gathering of particle physicists. And it's the first new particle found using the upgraded LHCb detector, which received a major overhaul completed in 2023. It's actually the 80th particle ever discovered by LHCb since operations began.
The signal was detected with a statistical significance of 7 sigma, well above the 5 sigma threshold required to officially claim a discovery, and it also settles a long-standing dispute. Over 20 years ago, an experiment called CELEX claimed to have spotted the same particle at a much lower mass, but no other lab could confirm it. This LHCb result at a mass consistent with theoretical predictions finally resolves that mystery.
Why does this matter? Because studying how these exotic heavy quark particles behave and how they decay helps physicists better understand the strong nuclear force, which is the force that binds quarks together inside protons and neutrons. The better we understand that, the better we understand matter itself at its most fundamental level.
Particle physics doesn't always make the loudest headlines, but every time we add a new entry to the subatomic zoo, we learn a little more about what the universe is actually made of.
Now let's zoom out, way, way out, from subatomic particles to an entire galaxy.
The small Magellanic Cloud, a dwarf galaxy that's one of the Milky Way's closest neighbors, visible to the naked eye from the southern hemisphere, has long been one of the most studied objects in the sky. Astronomers have cataloged its stars, mapped its gas, and tracked its motion for decades. But one stubborn mystery has persisted. The galaxy's stars simply don't orbit around its center the way stars in most galaxies do. Instead of rotating in an orderly fashion, their motions appear chaotic and disordered.
Now, a team of astronomers from the University of Arizona, led by graduate student Himansh Rathore and senior author Professor Gertina Besla, have cracked that mystery. And the answer is dramatic. The small Magellanic Cloud crashed directly through its larger companion, the Large Magellanic Cloud, a few 100 million years ago, and it's still reeling from that collision today.
The LMC's immense gravity disrupted the SMC's internal structure, sending its stars into wildly different random trajectories. At the same time, the dense gas of the LMC applied enormous pressure to the SMC's own gas as it punched through, destroying its gas rotation. Rathore described it beautifully. Imagine sprinkling water droplets on your hand and moving it through the air. As the air rushes past, the droplets get blown off by the pressure. Something similar happened to the SMC's gas on a galactic scale.
What's particularly fascinating is that for decades, astronomers thought the SMC's gas was rotating. It turns out that was an illusion of viewing angle. The collision is actually stretching the SMC, and gas moving toward and away from Earth along that stretch just looks like rotation from our perspective. It's one of those wonderful moments where what we thought we were seeing was something completely different.
The collision has also left some lasting scars on the Large Magellanic Cloud, including a tilted bar-shaped structure at its center, tilted out of the plane of the galaxy by the impact.
And this discovery has an important implication beyond just understanding these two galaxies. For decades, the SMC has been used as a benchmark, a kind of cosmic yardstick for understanding how early universe galaxies formed and evolved, because it's small, gas-rich, and low in heavy elements. But if it's a galaxy still recovering from a catastrophic collision, it may not be the clean reference point we thought it was.
As Professor Besla put it, the SMC went through a catastrophic crash that injected a tremendous amount of energy into the system. It is not a normal galaxy by any means.
The research is published in the Astrophysical Journal, and the team says this is just the first step. They now want to build detailed models of the full collision to understand how it's shaped the SMC's stars, gas, dust, and even its invisible halo of dark matter.
Galaxy next door, transforming before our eyes.
Dory 5 takes us from colliding galaxies to a very different kind of cosmic companion, tiny asteroid-like objects that share an orbit with a planet around another star.
These are called Exotrojans. To understand the concept, you first need to know about Trojans in our own solar system. In our neighborhood, there are more than 10,000 confirmed asteroids that orbit at special gravitational sweet spots called Lagrange points in front of and behind Jupiter on its path around the Sun. At these points, the gravitational pulls of the Sun and Jupiter balance out, allowing objects to essentially hitch a stable ride along with the planet.
Virtually every planet in our solar system has Trojans, though none come close to Jupiter's impressive collection. And for years, astronomers have theorized that similar co-orbital companions, Exotrojans, should exist around planets orbiting other stars. After all, if the physics works here, it should work everywhere.
The problem, no one has confirmed one yet. Projects like the Troy Initiative have been specifically hunting for Exotrojans, but these objects are extraordinarily difficult to detect. They're small, they don't produce much of a signal, and disentangling their presence from other noise is genuinely challenging.
A new paper in the Astrophysical Journal by Jackson Taylor of West Virginia University and a team of co-authors has pushed that hunt into some of the most extreme environments astronomers can imagine. The team searched for Exotrojans in conditions far more intense and exotic than anything in our own solar system, taking the search to new limits.
While no confirmed detection has been announced, research like this is essential for two reasons. First, finding Exotrojans would tell us a huge amount about how planetary systems formed and evolved. Trojans are essentially preserved remnants of the early solar system, little time capsules of planetary formation history. Second, some researchers have speculated that Trojan regions around habitable zone planets could themselves be interesting places in the context of astrobiology.
The first confirmed Exotrojan will be a landmark discovery, and research like this is steadily narrowing down where and how to look.
And we round out today's episode with a big question about an even bigger search: humanity's hunt for signals from alien civilizations.
The search for extraterrestrial intelligence, SETI, has been underway in various forms for decades. The classic approach has focused on scanning the sky for radio or microwave signals in very narrow frequency bands. The reasoning was that any technological civilization might use these wavelengths to communicate, and narrow-band signals are easier to distinguish from natural cosmic noise.
But a new paper is arguing that this long-established approach may be leaving us blind to a huge swath of potential signals. The researchers suggest it's time to broaden the electromagnetic search dramatically, moving beyond just radio and microwave into a much wider range of the spectrum.
The logic is intuitive once you think about it. Our own civilization's communications have changed dramatically, even just over the past few decades. We've moved from narrow-band AM radio broadcasts to broadband internet signals, which are spread across wide frequency ranges and might actually look more like background noise to an outside observer. A civilization more advanced than ours might communicate in ways that look nothing like what we've been searching for.
There's also the question of what we might be missing in other parts of the spectrum entirely. Infrared, optical, ultraviolet, even higher energy bands. All of these could theoretically carry engineered signals that we simply haven't been systematically scanning for.
This doesn't mean the traditional radio SETI searches have been wrong. They've been enormously valuable, and the infrastructure built for them has led to real astronomical discoveries. But as our tools and computing power improve, expanding the search makes sense.
The universe is enormous. Intelligent life, if it exists elsewhere, might communicate in ways we haven't yet imagined. And the electromagnetic spectrum is vast. Casting a wider net seems like exactly the right thing to do.
If there's someone out there trying to reach us, let's make sure we're actually listening on the right channels. Story 6. And that's our episode.
What an extraordinary day to be following the cosmos. A moon rocket rolling to the pad, 2 space stations running EVA simultaneously, a new particle from CERN, a galaxy in transformation, and humanity still reaching out into the dark, hoping to hear something back.
This is why we do this every day. Thanks so much for spending part of your Thursday with us, everyone.
You'll find links to all of today's stories in the show notes, along with our blog post and all the ways to follow us on social media.
Astronomy Daily is part of the Bytes.com podcast network. Find us at astronomydaily.io and on X, Instagram, TikTok, YouTube, and Tumblr at AstroDailyPod.
Until tomorrow, keep looking up.
Clear skies, everyone.
Astronomy.